good afternoon, one and all.
Okay, very good
This is
afternoon, one and all.
Dr. Sudhakar,
This is
Associate
Dr.
Professor from
Sudhakar.
Department of Anatomy. On behalf of organizing team BMSCON, I welcome our guest speaker, Dr.Ravikumar Sambandam, then chairperson, Dr. Jagrati Agarwal, then another chairperson, Dr. Archana Rani, and all delegates to that last talk of second day scientific program. It's my pleasure to introduce our chairperson, Dr. Jagrati Agarwal. Dr. Jagrati Agarwal, Professor and Head, Department of Anatomy from Pandit Jawaharlal Nehru Memorial Medical College, Raipur, India. Ma'am completed his graduation from Pandit JNM Medical College, Raipur. Also, post-graduation like diploma in ophthalmology medicine and surgery from the same college. MS Anatomy also from Pandit JNM Medical College, Raipur. Ma'am has been worked as a medical officer from 2001 to 2006 and also as a private practitioner in ophthalmology. Ma'am also worked as assistant professor at Pandit JNM Medical College, Raipur from 2009 to 2015. Then worked as an associate professor from 2015 to 2020. Then ma'am currently working as a professor and the head of department from 2020 onwards. Ma'am published more than 8 publications, both in national and international journals. Ma'am also life membership in All India Ophthalmological Society and also in Anatomical Society of India. We welcome you, ma'am. Next, I would like to introduce another chairperson, Dr. Archana Rani. Ma'am, professor in anatomy, King's George Medical University, Lucknow. Ma'am completed his graduation from BRD Medical College, Kharagpur, and MS from King's George Medical University, Lucknow. Ma'am has been more than 20 years of experience in teaching as well as academic part. Under its professional achievements, ma'am is editor and reviewer in many international and national journals. She's also chairman, editorial board of Journal of Anatomical Society, published by Department of Anatomy, King's George Medical University, Lucknow. Ma'am has also received Professor O.P. Kanduri Memorial Gold Medal Award for the best paper in the annual conference of UP chapter of ASI 2015. Ma'am also received Best Paper Award under Gross Anatomy category in National Anatomy Conference in 2021, conducted by Tirthakar Mahavir Medical College and Research Center, Moradabad. Ma'am published more than 99 papers, both in international as well as national journals. We welcome you. Welcome you, ma'am. Now I request Dr. Jagrati Agarwal to introduce our guest speaker, Dr. Ravikumar Sambandam. Over to you, ma'am. Ma'am, please unmute yourself and introduce the speaker.
Thanks, sir, for introducing me. Good afternoon, everyone. First of all, I want to congratulate BMSCON team for organizing such a wonderful and very well organized conference. And thanks for giving me the opportunity to introduce such an immense personality, Dr. S. Ravikumar. It's my pleasure, sir. Dr. S. Ravikumar is Principal Scientist in Multidisciplinary Center for Biomedical Research, AVMC College and Hospital at Vinayaka Mission Research Foundation since 2017. He completed his PhD in Biochemistry and Molecular Biology at Pondicherry, Central University, India. He has worked more than 9 years in South Korea as a postdoctorate research professor and assistant professor at Pusan National University, University of Ulsan, Catholic University of Korea, and Chennai National University. His research interests lie in the area of diagnostic, pharmacogenetic, genetic engineering, and evidence-based therapeutics. He has collaborated actively with researcher in several other disciplines of bioinformatics, health informatics, and nanotechnology. He has also published more than 50 research articles in Index Journal, Proceedings, and books, and also received one patent. He also presented lectures and oral presentation as the keynote speaker at the various scientific meetings. I am eagerly waiting for your session, sir.
Thank you, madam. Thank you very much for the introduction. First, I'd like to thank the organizing committee of BMSCON, and a special thank to Dr. Rajan sir and Dr. Ilangadi, the head of the Department of Anatomy. Today, I'm just going to talk about the role of 3D printing in healthcare and research. So my slide is visible, sir?
Yes, sir. Your screen is visible. You can start your presentation.
Thank you, sir. So myself, Dr. S. Ravikumar, I am basically a synthetic biologist as a background. Presently, Assistant Director Research and Associate Professor of Center for Biomedical Research, AarupadaiVeedu Medical College, Pondicherry. I'm doing the 3D printing for the past 2 years with several challenges. So now we are just trying to print the materials in immense easier way. So this presentation, I'm going through a real basics of 3D printing and creating the awareness of 3D printing technology among the medical fraternity. So my talk will start like this. What is a 3D printing? How to do it and how to design the 3D models, and going to talk about how we are going to apply the 3D printing technology in healthcare facilities. So the overall challenges in healthcare is that accessibility. So most of the well-equipped hospitals are located only in the Tier 1 and Tier 2 cities, and the people from the towns and villages has to reach the big cities for the proper healthcare facilities. The second one is the logistics and turnover around time is unpredictable in any part of the world as well as any part of the country. The second one is that expensive infrastructure. So the hospital has to procure the costly equipment and facilities, and it is very difficult in very low resource settings. So we can't able to establish all the infrastructure in one place. So this is a second challenge faced by the healthcare industry. And the third one is the high expertise. Either if you talk about the clinicians or the diagnostic equipment, to run the diagnostic equipment, we need a skilled manpower. The skilled manpower is very much required, and the protocols and the procedures, it's very, very complicated. So these are the overall challenges in healthcare. So there is a saying that if you want new possibilities, we need to create a new tools. So 3D printing is such a tools, immense tools, powerful tools, which can able to make the clinicians or healthcare or any areas, it gives an easier solution for our day-to-day problems. Usually the medical practices has changed over the years. So this is a picture of an operation theater exactly 100 years ago. The surgeon operates the patient with their students. So it is not a sterile environment. We know that it is not a sterile environment, and no technology has been involved. So this is happening in the last centuries. But at present, if you see that the operation theaters look like this. So you have a lot of technology involved in it. So robotics, several technologies have been implemented at present. And we have a sterile environment, and only the limited staffs have been working in this condition. But in the future or the next generation, the things will be look like we will be having a 3D printer, and you have a 2 or one staffs, and you will be printing the materials and then doing the surgery on time. So if this is happening, already the organ bioprinter, a lot of organs have been coming out of this for this printer, from this printer. So this is how the futures will look like. So going to the 3D printer evolution in mid 1980, the Japanese scientist comes with a new model for printing the rapid prototyping. So in 1990s and 2000, there is a powerful tool that is a CAD. They have tried to incorporate it for 3D printing. So this is a revolution actually. And the next one is that in 2000, they have created a working model for kidney. In 2010, the Cornell University built a 3D foot printer, and 2020, the Danish Kelly's lab launched a 3D printer for 3D printed bone. So in 2021, the biggest challenges in 3D printer is that the material usage. So we need to customize the materials for our the printed products. So if you look into that, the hydrogels, fibers, bio-based powders, mineral-filled materials now coming into the light, so that whatever you wish, you can able to take a printout. The future is a bioprinting that leads to the 4D printing actually. So what is 3D printing? We can say that it is an additive manufacturing. So 3D printing is a process of making a three-dimensional solid object from a digital file. So the creation of a 3D printed object is achieved by using an additive process. So in manufacturing industries, there are two types of manufacturing industries exist. One is additive manufacturing, another one is subtractive manufacturing. So if you take additive manufacturing, it reduces the energy and it reduces the material cost up to 90%. And there will be a 0% of wastage when compared to the subtractive manufacturing. So subtractive manufacturing is that many the wood carvings or the carvings from the stones. So these are called the subtractive manufacture, where a lot of wastage will be observed. Whereas in the case of additive manufacturing, so there will be a 0% of wastage. Coming to the 3D printing market in healthcare. So most of my pictures, I've been downloaded from the internet. I just want to be informed. So the healthcare 3D printing helps in various industries like dentistries, hearing aid, surgical guides, medical components, tissue engineering, even pharmaceuticals. The drugs have been manufactured by using a 3D printer. And several implants like prosthetics and implants have been from the healthcare industries. If you see the market, at present, the dental 3D printing market is the most mature one and accurate. They have a special type of software to their problems. So the high-speed printers delivers a smooth surface finish for crowns and orthodontic models, which can be created on site. But the next one is a hearing aid. 96% of hearing aids have been printed out by using a 3D printer in the world, actually. So other industries and other areas, actually, we need to make an effort to use this technology. So the technology gives us the whatever we want. This you can, by using this technology, you can able to take a printout. Coming to the workflow and implementation, it is a very simple workflow. Only the initial part, it will be the challenging. After that, it is a very simple process. So initially, we need to create a CAD model. So where you need to create a 3D file, you need a CAD software to do this one. So whatever object you want to, you can draw it in a 2-dimension, and then you can convert it to 3D by using this CAD model software. Once the 3D file is created, you need to convert this 3D file into an STL file format. for recognition of a design file for the printer. After converting this STL file, you need to slice it. What do you mean by slicing? Slicing is nothing but adjusting of a model size. If you want a model to be printed in 2 centimeter, or if you want to print a models in 20 centimeter, or if you want to print a model in 30 centimeter. So you can able to adjust during the process of slicing. And the location and orientation, in which orientation you want to print the materials, that also can be determined by using a slicing software. So if this part is very, you have done it in a, if you are expertise in doing this part, then the remaining part will be very, very easier. That is, you can do we can just send the file to the printer will take the printout for you as like a normal 2D printer. The final step is that post-processing, where you are going to remove, clean it. If you want to cure it, you can cure it. Or if you want to do a painting for many anatomic models, you can do that one. So that will be the post-processing. So these 5 steps involves in the workflow and implementation of 3D printing. So the most important point is that design using CAD. So CAD is nothing but a computer-aided design. There are several free CAD softwares are available, but the paid one you can able to customize as you required. But this free CAD software will guide you to make a user-friendly kind of products. Okay, so there are 2 types of free CAD softwares are available. There are multi, but these 2 are very familiar one. One is an Onshape CAD, another one is a Tinkercad. So both softwares are looking very good, and most of my students work in this one to get the product done. The next one is a 3D slicing software. This is also available in the net, but if you are procuring your 3D printer, the instrument during the installation itself, this software will be installed, where you are going to slice the 3D object. So coming to the next one is a type of printing technology. There are several type of printing technologies that I'm just putting into in a simple manner. One is a powder solidification, another one is a liquid solidification, and third one is a extrusion-based system. So based on this technology, there are several 3D printers are available. So only thing is that you should be very clear what materials you are going to use and what type of output you need, so that you have to choose your printers. So choosing a printer and choosing the material is very, very important in this technology. So in powder solidification, there is 2 things. One is a selective melting, another one is a drop-on solid deposition. In liquid solidification, there is a stereolithography and drop-on liquid deposition. And third one is that the fused deposition modeling and pressure assisted syringe. So where here the pressure is applied so that the printer will print layer by layer the object. Coming to the material, there are several materials are available today, but these are the materials that have been widely used in healthcare. One is a resin, carbon fiber. I think there is a mistake. That is powders, iron powders, and ninitol and plastics. So these are the materials have been used for 3D printers. So choosing the materials is very foremost important for the 3D printers. So why is this relevant for healthcare? If you take PT or OT or rehabilitation, prosthetics or orthotics, you need the aesthetic orthotics as well as developing a functional device for disabled veterans. So you can also print the sockets. You can also customize the prosthetics as you need. So as I earlier informed that 96% of hearing aid has been manufactured by using 3D printed technology in the world. So the next one is a biomedical engineering or a facility engineering. So as a working in a medical college, you need the tools for in OT or small tools you needed for day-to-day life. Those things also can be printed out by using the 3D printer. The next one is radiology and surgery. So if you want to make anatomy models from the MRI, laser, CT scan or USG or X-ray data, you can able to develop an anatomy model for from the imaging sources. So that next one is a dental. So it is a very matured industry where most of the implants and from the data generated from the radiographies has been implemented. So finally, the education, the model for displaying to the patient, whether it is clinically happening and also for staff training. So this is a advantage, or it is very relevant for healthcare. Only thing is that we need to explore. So why do we want to do this actually? First one is the cost saving. Nearly 10 to 20% of your cost will be saved when you take a printout, rather if you purchase from the market. So the next one is that it will decrease the turnover times. It is very, very important in healthcare industry so that the complication for the patient will be addressed immediately. The next one is it is a customization for us, patient-specific needs. So once this file has been stored in your database, and this can be retrieved any time when it is needed. So you don't need for any kind of manufacturer or any other person to retrieve this data. Overall, it will increase the patient satisfaction. So coming to the development of anatomy model. So there are several techniques to develop an anatomical model. One is a plastination, where the wax, using the wax technology, implicating into the organs, and then they are trying to act as a mold, and then from that mold they can prepare the model actually. But by using this 3D printer, you can develop any type of models. The only thing is that you need a scanner, or you can get the information from MRI or CT scan or X-ray data. And this X-ray data has to be fed into the CAD software. And there is another software called a segmental software, where you can able to get the information layer by layer to print out the system. So how this model is going to help the healthcare people is that it will give an idea or a planning for a pre-surgical operation, or it will give you a surgical stimulation. If you want to do a stimulation kind of things, it also helps in before the surgery happens. And it can be an education material for a staff and resident in the hospital. And you can also inform to the patient about what is really happening in their system. Finally, it can be a surgical aid tools. So only thing is that you have to collect the data from the MRI, or there is 3D scanners are available. So from that information, you have to feed it into the software, and the software will take the printout. This is a straightforward methodology, and we need to work. We have nearly 21 to 25 departments in the hospitals. So each one has to come up with their ideas to print their models, so that it will be useful for the education wise as well as for the surgical protocols. The next one is development of a drug using a 3D printer. So now the pills have been printed out by layer with the help of water-based layer, so that you get the pills from a Zippos. The result of this tablet can dissolve the in water within 5 seconds. Actually, if you put it into the water, it can dissolve in 5 seconds. It comes from Aprecia. The next important technology is 3D bioprinting. It is little different from the 3D printer, where the most latest technology is a biofabrication of a living structure using a tissue engineering. So if you see the process, there are 3 important processes. One is the pre-processing, processing, and post-processing. If you look into the pre-processing, there is 2 things. One is imaging. So as I told earlier, you have to collect the data from the X-ray, MRI, or CT scan or ultrasound, and then you have to put this image into the CAD software, where the CT image is converted into 3D model, and then it is converted to a ST file. After that, the slicing will be happen. Once this process is completed, so the next one is a processing, where this 3D printer will have a bio ink. So the bio ink is made up of cell cultured laden, along with the tissue material. You can able to do the 3D printer. So once the 3D, once you get the tissue or organ, so you need to do the post processing. So this post processed material can be used in vitro. Most of that nowadays, now they are just doing a study in vitro models. In later stage, it can be transplanted to the human beings. So the current progress is that bioprinting the human ear. So many children with malformed outer ear can utilize this bioprinting human ear. And the next one is bioprinting layer by layer kidney cells. So they are trying to bioprint the kidney cells. And then the last one is that they make printed bones by using a titanium powder in order to repair the complex fractures in any accidental. So what will be the future of the bioprinting? So today you can able to print the bones, the skin, tissues, and organs today. But after 10 years, you can able to do a specific organ tissue replacement, example, heart and kidney. And you can also personalize the replacement of 3D printed joints with a custom prints. And the third one is that life-saving 3D printer for organ replacement. So at 2040, 20 years later, you can look into the bioprinting technology. It will be the replacement of 3D printed organs at an affordable price. Liver and kidney replacement companies reach the maturity, and 3D printed replacement for all human bodies will be available. So this will be the future bioprinting. And the need of the hour is that in last century, we screened the many disease condition, and we couldn't able to come to a conclusion, and it is a little bit inaccurate. But at present, we have some kind of technology will give you the result, but it not in an emergency based or with a very low resource settings. But in the next generation, if you see, there will be a point of care technology. Already it is emerged. The system is called as a microfluidic device, where you need to have a very low sample size, very low reagents, and it is if you think about it, is not very expensive. It is a cost affordable. So this microfluidic device for the detection of foodborne pathogen. Actually, this system has been developed by from our lab. His name is Dr. Ganesh. So he has developed this microfluidic detection system. So here, if you look into that, we need to make 3 chambers. One is a microfilter. The second one is the magnetic nanoparticle chamber and the PCR chamber. All these chamber has to be designed in the software, in the CAD software, and then they have to take a printout in a separate chambers. Once they take the printout, what happens? They have to assemble it. They have to fabricate it into a unit. So what this microfluidic device do? Actually, if you see this, you have a microfilter. So the food particles has to be homogenized, and then if you see here, you can see that it will contain some kind of bacteria. So this bacteria has to be entrapped by using a magnetic nanoparticles, which is coated with an antibody. So once it is trapped, so you need to, the step 2 will be passed through this filter, this microfilter. So all the cell debris and other waste material will be settled down, and then the remaining suspended particles will be in the second chamber called MNP chamber. In this MNP chamber, if you look at, if you put some kind of magnet on the down, it will entrap all the binded nanoparticles on the surface of the MNP chamber. After that, you have to put the third chamber inside, that is a PCR chamber, where you are going to put the PCR reagents as well as the entrapped materials into the chamber. So these reactions take place in the normal temperature incubator. So the amplification is can be done here. So what is happening actually here is that you can able to determine the pathogens, the foodborne pathogen, by using this microfluidic device. This microfluidic device can be printed out by using a 3D printer. So these are some of the models has been printed in our facilities. So usually whenever the gel casting tray has broken or the foam broken, we usually order to the company, and then we purchase it. But since we have the Ultimaker and the Dreamer, what we do that is that we print our day-to-day consumables, the gel casting tray and foam for our day-to-day activities. Similarly, we also try to print out the centrifuge, that is a mini spin, by using our 3D printer. We assembled it, and then the system is working very well also. And one of the assistant professor, Dr. Prithviraj, has been working on the fabrication of 3D printed PLA scaffold with dopamine. So for checking the bone tissue regeneration. So he also is printed the scaffold by using the 3D printer. So what is the challenges in implementation of this 3D printing technology for biomedical products? There are two big challenges. One is the processing, another one is the management. The processing is a printer. So you need to be very careful what type of printers you need for your work. So that based on that, you need to choose your printer. Similarly, materials also. You need to find out that the distribution of size, the texture, what kind of texture you need. Once if you are looking only for the anatomical model, you have to be more specific in choosing the printers and the materials. Finally, the management. So you need to re-educate the staffs. You need to create the awareness among the staff because the people thinks differently. So you can also expect more products can be generated by using this kind of 3D printer. The next one is the size of the business is very less. These are the areas we need to look into in managing or implementing the 3D printing technology in healthcare. So finally, this is our research team. Thank you for your valuable time. So I'm ready to answer if you have any queries.
Thank you, sir. It was really a wonderful presentation.
Thank you, sir.
You beautifully explained about the role of 3D printing and its clinical applications in various fields, research and anatomy, sir. It was really wonderful presentations and more informative, sir. Thank you so much, sir.
Thank you, sir.
Over
Thank
to
you.
Chairperson, ma'am.
Thank you, Dr. Ravikumar, for elaborative and interesting topic on 3D printing in research. And definitely Soon we'll see the 3D printers in the medical field will be able to create tissues to help with skin grafting and reconstructive surgeries also. And now I request all the participants, if they have any question regarding the talk, they can put their queries.
I think there is no queries in the chat box.
I think people understand more.
Yeah, it was nice presentation, sir.
Yeah, it was very nice, and actually it is a very recent topic, so not much have to ask by the participants.
The most challenging part here is that we needed to learn the CAD software. So if you can able to understand the operation knowledge of using the CAD, then you can able to create more models, anatomic models, which will help the students and the faculties to understand what is really happening in the system actually.
Just I want to ask one question. What is one model and this which will come out after the 3D printing?
I'm not getting, madam.
What is the difference between plastination, the models which we procure from plastination in anatomy, and the 3D printers, which the models which will come out from the 3D printers? What is the basic difference between these two?
So both are same. The materials what you are using in the plastination will have some kind of limitation. You can use only those materials alone. But if you want to use it in the 3D printer, you can use any type of material. As I already told, you can use a resin, you can use carbon fibers, you can use nanitol. So those things will be, you have a choice for using the materials for doing a 3D printer. So if you take the implants needed kind of metals or ceramics. In that only you can able to print it. It will go for an application part, whereas the plastination will be the model generated part. So here this 3D printer will be helpful in both generating the model as well as the application part actually.
So one question from delegate, sir.
Yes, sir.
That question is, what is that recurring cost for consumables?
Recurring cost is very much cheaper when compared to the in earlier stage. Actually, 2 years or 5 years before, the charge is very expensive one. But now the graphite thing itself is coming down. Actually, because it comes in a wire format, so it is very cheaper. It is not very expensive, and if the products manufactured through the 3D printer also is very nearly to 5 to 10 times lesser than the actual cost actually.
I think since there is no further queries in the chat box, I think we'll go to conclusion, ma'am. Okay, sir. Sir, thank you so much. As a token of appreciations, we would like to honor you with the certificate and memento. Thank you so much, sir.
Thank you very much, sir.
Thank you.
And as a token of appreciations, we would like to honor our chairperson, Dr. Jagriti Agarwal, with the certificate and memento. Thank you, ma'am. Then I would like to honor the chairperson, Dr. Archana Rani, with the certificate and memento. Thank you, ma'am.
Thank you, sir. Thank you, madam.
Thank you.
Thank you.
So once again, I thank guest speaker, Dr. Ravikumar Sambandam, sir, and chairperson, Dr. Archana Rani and Jagriti Agarwal for your active participations. Thank you all.
Thank you, sir.
Thank you. So the session is concluded, and that session for the scientific session for afternoon will be continued. Thank you all.